All right, so good evening, everyone. This afternoon, we'll be looking at first correcting these patterns and sequences assignment that was given. It's actually taken from the January 2020 core paper, right, which would have been Jan this year. So it says the number of white counters W and the number of black counters B and the total of counters T that form the shape follow a pattern. The values W, B, and T for the first three shapes are shown in the table below. It says to study the pattern of numbers in each row and answer the questions that follow. Right, so anytime we are given a question like this, what we could do is we could take it column by column with your figure number, right? So in this case, instead of having figure number, they have your shape number, right? And we could have it column by column. So what we do is we take the first column, which is your figure number, or in this case, which is your shape number. And I'm looking at the number of white counters. Now, what you want to do is you want to look out for a pattern. And the pattern must always include your figure number. Now, if you notice something, as these numbers changed, there were some of them that remained constant, right? So for example, these remain constant. So in the first bracket, what you can observe is that as we went through them, we saw that this number changed with respect to your figure number. So when it was 4, that means this would have been 4 plus 1. And in this case, we saw that 2 times a number, and this number here also changed with respect to your figure number plus 1. Right, so this one, if we had 4, it would have been 4 plus 1 into 2 times 4 plus 1. So what we are seeing is that the first number is actually changing with respect to your figure number. So if my figure number is n, that first number is going to be n. So it'll be n plus 1 because 1 remained constant. And then it was 2 times the figure number. So if my figure number is n, then it'll be 2 times n, and then we add 1. So basically, that's the formula. Your formula would be whatever is your figure number, your shape number, plus 1 times 2 times whatever is your figure number, which in this case is n, and then we add 1. So this will be the formula for the number of white counters. All right, so we figured out what was our formula to find the number of right counters? Now, I have two missing lines here. So really and truly, I can't figure out anything he has yet. So what we do is we move on to the next column, which would be the black counters, right? Because we can't get any further information there, we move on to the next set, which would be the black counters. So you are going to compare your shape number to your number of black counters. Now, if you look at it, it was always some number plus 1 all squared. And the number was the same number as your figure number or your shape number. So if it goes down to n, it will become n plus 1 all squared. Similarly, if this was 4, this would be 4 plus 1 all squared, which would be 4 plus 1 is 5, and 5 squared would be 25. Now, I know in order to find the number of black counters, it's going to be n plus 1 all squared. Now, the n plus 1 all squared was equal to 144. So we could use this information in order to figure out what is the shape number, or what is the value of n in that case. So in order to solve this algebraic sum, I first want to carry everything across the equal sign. Think of your equal sign as a portal. And once you cross the equal sign, you do the opposite operation. So if you were adding, the opposite is minusing. If you were minusing, the opposite is adding. Multiplying, the opposite will be dividing. Dividing, the opposite will be multiplying. Square, the opposite will be square root, and vice versa. So the first thing I want to do is I want to carry across the square. So when it goes across, the opposite of square will be the square root. So we find the square root of 144. That is going to be 12. Then we're going to carry across the 1. That 1 was added. So when it goes across, it's going to be the opposite. So it's going to become minus. So n will be 12 minus 1. N is going to be 11. So that means the figure number or the shape number here is going to be 11. So I know my value of the shape number is 11. All right. So now that we know that the figure number for this one, or the shape number, was 11, I could substitute it into the formula. Right? Remember, we had a formula which was n plus 1 and then 2n plus 1. So this will be your n. N is 11. So 11 plus 1 multiplied by 2 times n. So that's 2 times 11, 22 plus 1. So 11 plus 1, that's 12. And anytime you have brackets without anything in between, we understand that they're multiplying by each other. So 22 plus 1, that's 23. So you'll end up with 12 times 23, and we got 276. All right, so pausing here. All right, so take a look at this one. Now they want to know the number, total number of counters if the figure number is 4, but they already gave you the formula. So all we have to do is just to substitute 3n squared plus 5n. Wherever I have n, I'm simply going to put 4. So that will be 3 times 4 squared plus 5 times 4 plus 3. 4 squared, 4 4s are 16. 16 times 3. 5 4s are 20 plus 3. Right, so this becomes 16 times 3. That's 48 plus 20 plus 3. That would be 71. So 48 plus 20 plus 3, that's 71. So that means the total number here would be 71. All right, so let's pause. Wait, I have an error. It wasn't add 3, it was add 2. You'll see it, it was add 2. Right, so it would have been added 2, not 3. Right, so that would have been 48 plus 20 plus 2, which is 70. Right, so the total would have been 70. All right, so pausing here again. All right, so we're going to move on to the topic of quadratics. Now, we must know that a quadratic is always in the form of ax squared plus bx plus c. There are several ways you can solve a quadratic. The first way is to solve it through factorization, like what we did in the previous recording. So factorization. Or you could solve it using the formula or you could solve it by completing the square or they could ask us using graphs. right? So we have a number of ways that we can solve quadratics. Now, what I'm going to do is I'm going to look at solving quadratics through factorization. Now, when it is you are factorizing, they can ask you to factorize a quadratic. However, if they ask you to solve a quadratic, it means that your quadratic is going to be equal to 0. Now, let's say they gave us a quadratic. So they gave us this one to solve. Right, so we first have to factorize following the same rules as before. So let's pretend they gave us x squared plus 3x plus 2 is equal to 0. Right, so if they tell you to solve, it means that you have to put your quadratic equal to 0. But we're going to factorize like normal. So let's factorize it first. Remember the steps when factorizing. Right, so remember the steps when you were factorizing. This would have been multiply. So you label your equation as the ax squared plus bx plus c. Multiply the value of c by the value of a. You're going to find two numbers, which when multiplied will give you that product. And at the same time, when you add the same two numbers, you'll get the number in front of b. It's going to expand your middle term, and then we had to factorize by grouping. Right, so you're following through with your rules. This here is going to be ax squared plus bx plus c, where a is 1, b is the number in front of x, which is 3, and c is your constant, or the number that stands alone, which is 2. The first step is that you're going to multiply c by a. So c by a, when I multiply those two, I'm going to get 2 times 1, which is 2. And I want to find two numbers, which when multiplied will give me 2, and when added will give me the number in front of b, which is 3. So what I like to do is I like to look at all the ways I could multiply to get this number. The only way we can multiply to get 2 is 1 by 2. And if I add those two, 2 plus 1, I'll get 3. So those are my numbers. So we're going to take those two numbers. My first term remains the same. My last term remains the same. And I'm going to take those two numbers to break up the middle term. So this becomes 1x plus 2x. So the two numbers that we have here, I'm going to put x on them to break it up. Right? Because if you look here, this is 1x plus 2x, that's 3x. So I broke up the middle term, and now we have 4 terms. And anytime you have 4 terms, remember you have to do the factorizing by grouping. So we're going to follow through with those rules. Pair up my first terms, pair up my second terms. I'm going to factorize the first pair. X squared plus x in common is x. Nothing else is in common, so I divide both of these terms by x. X will go into x squared x times, the remainder goes inside of the bracket. X will cancel with x, so I'll be left with 1. Remember, we're going to copy what's in the brackets and paste. Ask yourself, what do I multiply by outside, by everything inside, so that we could get what's on top of here? And that's going to be positive 2. 2 times x will give me the 2x, and 2 times 1 will give me the 2. After that, I'm going to pull out one of the duplicated brackets. So I'll have x plus 1, and everything else that is not inside of a bracket, I'm going to put it into the other bracket. Right, so I have x and positive 2 outside, so we're going to put those two together in the other. It comes like we're factorizing it again, where we're pulling out the x plus 1. But in layman terms, to help us as we go through the steps, we could say pull out one of the brackets, and everything that is not inside of a bracket, we put it inside of the other. Let me get a center. Right, so we know that they could ask us to factorize. If they tell you to factorize, do so. It's because they're testing your skill in factorization. Now, what they could do is they could say, hence solve for x. Or they might say, hence solve the quadratic. In order to solve a quadratic, when you factorize, you're simply going to put it equal to 0. Now, if I have 4 multiplied by 0, anything multiplied by 0, we know is going to be equal to 0. So that means either this number is 0 or this number is 0. So what this simply means is that if the product of these is equal to 0, it means, therefore, that either this is equal to 0 or this is equal to 0. Right, so that means for me to have a quadratic like this, x plus 1 is equal to 0. Sorry. So it's either x plus 1 is equal to 0 or x plus 2 is equal to 0. So if x plus 1 is equal to 0, when I carry across the 1, we're going to do the opposite operation. So it's going to be x is equal to negative 1 or x plus 2 is equal to 0. Carry across the positive 2, so it becomes negative 2. X is equal to negative 2. So in a case like this, either x is negative 1 or x is negative 2. So for a quadratic, you're going to have 2 solutions. All right, so let's say they gave us one like this. Now, they might tell you to factorize it, or they might tell you straight up to solve it. Now, if they tell you to solve it, the only problem is not all quadratics could be factorized, right? And you guys might see that later on. Not all of them could be factorized. So in a case like that, you could jump straight to the formula, which I'm going to do next. But in this case, let's say they asked us to factorize it. They came out and told us to factorize it and hence solve it. So let's factorize it. So my first step is I'm going to label it so that I'll be able to know what are my various parts of the quadratic. So in this case, A is the number in front of x squared. In this case, it's 1. B is the number in front of x. In this case, it's negative 10. And C is the number that is on its own without a letter, and that is going to be negative 24. Remember, the signs are important. The signs are always in front of the number or in front of the term. Right. So first step is you multiply your C by your A. When I multiply those two, negative 24 times 1, that will be negative 24. And we want to know two numbers which when added at the same time will give us the number in front of x, which in this case is negative 10. What we are going to do is we're going to look at all the possible ways I could multiply to get the negative 24. So we know in order to get 24, I could multiply 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So we're going to look at which combination, when added or subtracted, will give me negative 10. So the two numbers, when we multiply them, it must give us negative 24. And when we add or subtract, we must get negative 10. I know you guys are thinking, Miss, 6 and 4. Yes, but in order for me to get negative 10, it must be negative 4 and negative 6. But when I multiply those two, it becomes, when I multiply those two, it will become positive 24. So it's actually not that. So it's not 6 and 4. If I add 8 and 3 or minus it, I will not get 10, so it's not that. If I add or subtract 21 and 1, I will not get 10. So we know it's not that either. Right? Because I can't add 24 to 1 in order to get it 10. However, if I subtract 2 from 12, I'll get 10. So I could use 12 and 2. All right, so negative 12 And positive 2 are the two numbers that when I multiply them, negative 12 multiplied by 2, I'll get the negative 24. And negative 12 plus 2, subtract, keep the sign of the bigger number. So it's going to be negative 10. So the two numbers that we'll use will be negative 12 and 2. So in your quadratic, we're going to use those two numbers to break up the middle term. So the first term stays the same. The last term stays the same, sign and everything. I could put the negative 12x plus 2x. So I'm going to put the latter variable onto each of them so that when I add them or subtract them back, I'll get what's in the middle, right? Because negative 12x plus 2x will give me negative 10x. Then we're going to factorize by grouping. Pull out what's in common in the first pair, which is x. And then whatever you pull out, remember, you look at the numbers and the letters. In this case, the HCF of 1 and 12 would have been 1. So I would have pulled out 1, but we didn't have to put the 1 there because it's understood. X could go into x squared. X times remainder goes inside of the brackets. X could go into x1s with a remainder of negative 12. Copy whatever's in the brackets and paste. Copy and paste. Then you try to determine what would I multiply by out here by everything inside that will give me back this. And that's going to be positive 2. Remember, these signs are important. So 2 times x will be 2x, and 2 times negative 12 will give me negative 24. Then we pull out one of the duplicated brackets. And then everything else that is not inside of the brackets goes inside of the other brackets. And that there we completed the factorization. But remember, they asked us to solve. And when we're solving a quadratic, we put it equal to 0. So we're going to put our solution equal to 0. So it's either that the first bracket is equal to 0, or the second bracket is equal to 0. Carry across, so x will be equal to positive 12, or x, when I carry across the 2, it becomes negative 2. So my answers, a quadratic, you're going to have two solutions. My answers will be x is equal to 12, or x is equal to negative 2. You put the both solutions, unless it is clear that they tell you that the value of x is a positive number, or so on. If it's a positive number, or like, let's say they gave you like a rectangle or something and ask you to find the area or something, and there was a quadratic, I believe there's a question like that I could find. then you know if you're dealing with measurements, it's only positive numbers. So you'll know that x will be 12 in this case because we're dealing with the positive numbers. All right, so let's say they just tell you to solve the quadratic. They didn't tell you to factorize or anything. You have the choice that you could use the formula. Now the formula is that x, which is the unknown that we're trying to find, is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, what we're going to do is that we're basically going to substitute our values. So let's say they gave us the same one, that x squared minus 10x minus 24 is equal to 0. So we already know that it's in the form of ax squared plus bx plus c. If it's not in that format, you put it into the format. And then you pull out your a. A is the number in front of your squared variable. Remember, it doesn't have to be x, huh? It could be any letter. It could be p, it could be r, it could be y. So the number in front of the squared variable, that's your a. So in this case, there's no number, but we understand that it's 1. B, my unknown will be negative 10. C, my unknown will be negative 24. And you're basically going to substitute it into your formula. So where you have B, remember you have negative B. So it's negative of the value of B. Be careful with your signs because it's negative of B and B is negative 10. Plus or minus the square root of B squared. B is negative 10, so that's going to be squared, minus 4 times A is 1, times C. C is negative 24. Do not forget your signs. All divided by 2 times A, which is 1. Then we're going to solve following our rules of BODMAS. Negative of negative 10. Anytime you have 2 same signs back to back, remember it becomes a positive. So negative 10 becomes positive 10. Plus or minus the square root of negative 10 squared. That means negative 10 by negative 10, which is 100, minus 4 ones are 4, times negative 24. All over 2 ones are 2. So you get that 10 plus or minus the square root of, I need to multiply this first because BODMAS tells me to multiply. So that's going to be negative 4 times negative 24, and we'll get 100 Minus by a minus becomes a positive, so it becomes plus 96 all over 2. So after this, we'll end up with, because remember, this is x is equal to now 10 plus or minus the square root of 100 plus 96 as 196 all over 2. So we find the square root of 196 first. That's 14. So we'll end up with x is equal to 10 plus or minus 14 all divided by 2. So it's going to be x is equal to 10 plus 14 divided by 2, or 10 minus 14 divided by 2. So 10 plus 14, that's going to be 12. Right, so that's going to be 10 plus 14, that's 24, sorry, over 2, or 10 minus 14, which is negative 4 over 2. So x is equal to 24 divided by 2, which is 12, or x is equal to negative 4 over 2, which is negative 2. So you realize you got the same answer. Sorry for the background noise.